For as long as humanity has looked to the stars, we have carried one burning question. Are we alone in the universe?
One of the most basic philosophical questions is, are we alone?
Is it all just for us? Or do we get to share it with anyone?
I mean, that's about as fundamental a question as you get.
For centuries, this question remained only in the realm of dreams and imagination. But then came a discovery so profound that it has reshaped our understanding of where life might exist. That discovery is K218b, a planet that belongs to the K218 star system. It circles around a cool, dim red dwarf star that shares its name, hidden deep within the constellation of Leo. This world is not impossibly far away. It rests at a distance of about 120 light-years from Earth. In the vastness of space, this is actually quite close, giving astronomers a unique advantage. Because of this proximity, they are able to study it in far greater detail than many other exoplanets scattered across the universe. And what a world it is. K218b is about 2.5 times larger than Earth in radius, and has a mass 8.5 times greater than our planet. With such extraordinary proportions, it is categorized as either a super-Earth or a mini-Neptune. But these are not just cold measurements. Its immense size tells us something vital. It means the planet is able to hold on to a thick, heavy atmosphere, the very thing that could shelter life and allow chemistry to work its magic. This protective blanket of gases could do more than keep the planet safe. It might serve as a stage for complex chemical reactions, perhaps even the very processes that one day give birth to living organisms. The story of K218b began in the year 2015, when NASA's Kepler Space Telescope first spotted it. Kepler was a pioneer, designed to detect exoplanets by watching for the tiniest dips in a star's light as a planet crossed in front of it. With this method, Kepler revealed the existence of K218b, marking it as a treasure for future study. 2 years later, in 2017, the Spitzer Space Telescope confirmed something extraordinary. K218b orbits within the habitable zone of its star, the region where temperatures might allow liquid water to exist. Suddenly, this was no longer just another planet. It was a world with genuine promise. Then, in 2019, the legendary Hubble Space Telescope brought an even greater breakthrough. Using its powerful instruments, Hubble detected water vapor in the atmosphere of K218b as the planet passed in front of its star. For the first time, scientists found evidence of a life-supporting ingredient on this alien world. The dawn of a new era arrived in 2021 with the launch of the James Webb Space Telescope. This remarkable machine, with its unmatched infrared vision and sensitivity, became our most powerful tool for probing the atmospheres of distant planets. Naturally, K218b, already glowing with hints of possibility, was placed high on its list of targets. By the year 2023, James Webb had delivered results that left scientists astonished. Its observations revealed the presence of dimethyl sulfide, an organic molecule that, on Earth, is produced almost entirely by living organisms, particularly microscopic plankton in our oceans. To find this molecule on a planet more than 100 light-years away was nothing short of breathtaking. But that was not all. Alongside dimethyl sulfide, scientists also detected methane and carbon dioxide in high amounts. This mixture of gases paints a tantalizing picture, because such imbalances usually suggest that something is replenishing them, often life itself. It may not be life as we know it on Earth, but it whispers of living processes at work beneath K218b's thick skies. Imagine it, a planet resting in the Goldilocks zone, not too hot and not too cold, with water vapor, organic molecules, and the chemistry of life unfolding in alien oceans. But if life does exist there, it would likely be very different from us. On Earth, intelligence grew hand in hand with fire, tools, and solid ground. But on K218b, there may be no land at all, only a world-spanning ocean, crushed under immense pressure, cloaked in near-total darkness. There, evolution could follow a path utterly unlike our own. Instead of forging tools from metal or using fire, creatures might develop living technologies, symbiotic relationships, microscopic ecosystems, or even organic systems they cultivate to survive. What we call technology here could be replaced by biology itself over there. This is why K218b is so important. It forces us to broaden our vision of life. For too long, astrobiology focused almost entirely on Earth-like rocky planets with plenty of sunlight. Now, ocean worlds once thought inhospitable are stepping into the spotlight as some of the most promising candidates for life. One great advantage lies in its star. Red dwarfs like K218 live for hundreds of billions of years, far longer than our own Sun. This incredible lifespan provides life with an almost endless stretch of time to grow, change, and perhaps even become intelligent. Of course, red dwarfs can be violent too, releasing powerful magnetic flares that could strip away a planet's atmosphere. Yet, K218b's thick hydrogen-rich envelope might act as a shield, preserving its potential as a cradle for biology. Water, with its strange and remarkable properties, is not just the foundation of a life on Earth. It is the silent engine driving nearly every chemical process that makes life possible. What makes water so extraordinary is its unmatched ability to dissolve a wide variety of substances. This is why it is often called the universal solvent. Because of this, water allows nutrients to move, mix, and react, fueling the complex machinery of biology. Now, imagine an ocean so deep and vast that sunlight cannot reach its floor. In such a world, photosynthesis, the process by which plants and certain microbes turn light into energy, could only take place in the thin upper layer of the water, where the last, faintest traces of light struggle to break through. Beneath that fragile zone, life, if it exists, would need to find an entirely different way to survive. On Earth, human beings rely on light and sound, especially hearing, to sense and communicate with the world. But in the crushing depths of alien oceans, light quickly fades into darkness, becoming useless beyond a certain depth. Sound, however, behaves differently. Unlike light, sound waves travel much farther and much more efficiently in water, especially at lower frequencies. If intelligent life exists within the endless seas of planet K218b, it might have evolved to master sound in ways we can hardly imagine. Much like dolphins and whales on Earth, which use sonar clicks, whistles, and long haunting calls to navigate and communicate, these possible beings may rely on intricate sound-based systems. Over millions of years, such a system could evolve into a fully structured and sophisticated language, a language of echoes and vibrations capable of carrying not only simple messages, but also detailed knowledge, culture, and memory. As of today, no scientist can say with certainty that life exists on K218b. The planet has not yet given us direct answers, but it serves as a reminder. If intelligence exists elsewhere in the universe, it might not resemble us at all. It could shimmer faintly in strange wavelengths, whisper through pressure waves in dark waters, or even pulse softly in electromagnetic patterns we do not yet understand. Life may be watching silently, or waiting patiently, beneath the oceans of that distant world. What makes K218b especially fascinating is that it shares three crucial features with Earth. Three conditions that scientists believe are essential for the beginning and survival of life. First, astronomers have detected water vapor in its atmosphere. This was first observed by the Hubble Space Telescope, and later confirmed in greater detail by the James Webb Space Telescope. The presence of water vapor strongly suggests that liquid water, the lifeblood of biology, could exist on the planet's surface. Second, the planet orbits its parent star within the habitable zone. This is the Goldilocks region, not too hot and not too cold, where temperatures can allow water to remain in its liquid state. This balance is vital. Too much heat would boil water away. Too much cold would lock it forever into ice. Third, K218b is massive enough to hold onto a thick atmosphere. Its gravity acts like a protective net, preventing gases from escaping into space. A dense atmosphere not only shields the surface from deadly cosmic radiation, but also acts like a thermal blanket, softening the extremes of day and night. This creates a more stable environment where life might flourish. Geological activity may also play a key role. On Earth, processes such as plate tectonics and volcanic eruptions drive the carbon cycle, stabilizing climate and replenishing essential elements. If K218b has similar internal activity, it could sustain life-friendly conditions for unimaginably long periods of time. But here lies the most intriguing possibility. Scientists now believe K218b might be a Haitian world, a type of planet first proposed in the year 2021. Haitian worlds are thought to have deep oceans beneath thick atmospheres, and remarkably, their environments may be even more stable than Earth's. Our own planet has endured ice ages, dramatic shifts in climate, and violent geological upheavals, yet life has survived. A Haitian planet, by contrast, could offer stability for billions of years, giving evolution a quiet and steady stage on which to perform. Why does K218b stand out among the thousands of other exoplanets we have discovered? The answer lies in a breathtaking figure, a 99.7% probability that the planet could host life. This number is not a guess. It comes from advanced statistical models known as Bayesian algorithms. These models weigh all available evidence and constantly update as new data is collected. The result is the highest probability ever recorded for a potentially habitable world beyond our solar system. And yet, science always leaves space for doubt. A tiny margin of uncertainty, about 0.3%, remains. This is not because scientists lack confidence, but because true science demands humility. Until we can see life directly, or touch a sample with our own instruments, all conclusions remain educated inferences. For instance, certain chemicals such as dimethyl sulfide might be produced by unknown geological processes, not by life. This uncertainty connects to the famous Fermi paradox. If intelligent life exists in the cosmos, why have we not yet seen clear signs of it? Despite this, in astronomy and astrobiology, a 99.7% probability is nothing short of revolutionary. It is not just a number, it is a beacon guiding research, inspiring funding, and motivating space agencies like NASA, ESA, and CSA to place K218b among their highest priority targets. The discovery of K218b and its potential biosignatures is not only a scientific achievement, it is a turning point in humanity's story. It pushes us from speculation into the realm of real evidence. If this world truly harbours life, it will transform how we see the universe and our place within it. But the journey is only beginning. What we see now are just the first clues, faint whispers from across space. Science is built on patience, on questions, on constant refinement. That is why we must continue to support exploration, push forward with new missions, and nurture the endless curiosity that has always driven us. The universe is vast, holding mysteries beyond count. Somewhere, perhaps in the deep oceans of K218b, life may already be listening. Astronomers have also made another exciting discovery, a new planet called TOI 715b, nicknamed a super-Earth, because it's about 1.5 times larger than our Earth. This planet is fascinating not only for its size, but also because it's relatively close to us in the vastness of space, sitting just 137 light-years away. To put that into perspective, most planets outside our solar system, known as exoplanets, are often hundreds or even thousands of light-years away, and cosmic wonders like black holes or colourful nebulae are typically much farther, often tens of thousands of light-years from us. So, finding a planet this close is like spotting a rare gem in our cosmic neighbourhood. Could TOI 715b be a place where life might thrive? Scientists are buzzing with curiosity about this question. They look at something called the habitable zone, which is like the Goldilocks zone around a star, not too hot, not too cold, but just right for liquid water to exist on a planet's surface. Liquid water is key because it's essential for life as we know it. However, being in this zone doesn't guarantee water is present. A planet also needs the right kind of atmosphere, the proper chemical ingredients, and other conditions to make it a cozy home for life. Back in 2014, scientists came up with a stricter idea called the conservative habitable zone to narrow down the best candidates for planets that might truly support life. This zone focuses on planets that receive about 40 to 85% of the energy Earth gets from our Sun. Excitingly, TOI 715b sits comfortably in this special zone, making it a prime candidate for further exploration. This super-Earth orbits a type of star called an M-type star, or a red dwarf, which is much smaller and cooler than our Sun, about 1/4 its size and mass. Red dwarfs are like the tortoises of the stellar world. They live incredibly long lives, much longer than our Sun, which is a yellow dwarf star. Our Sun is about 4.6 billion years old, but this red dwarf is even older, clocking in at roughly 6.6 billion years, give or take a few hundred million. This ancient star is calm, with low magnetic activity, meaning it doesn't throw out wild bursts of energy or flares that could strip away a planet's atmosphere. Younger red dwarfs can be quite feisty, blasting their planets with intense flares that might make life difficult. But this one seems to have settled down, creating a more stable environment for TOI 715b. One of the coolest things about TOI 715b is how close it orbits its star, zipping around it in just 19 days. Because the star is small and the planet is so near, it frequently passes in front of the star, creating clear signals that telescopes like the James Webb Space Telescope can pick up. This makes it easier for scientists to study the planet's atmosphere without needing to observe it for ages. The James Webb Space Telescope is like a cosmic detective, helping us peek at the gases that might swirl around distant worlds, even those millions of light years away. Right now, it's hard at work trying to figure out if TOI 715b has an atmosphere. If it does, that atmosphere might be easier to detect than on a denser, drier planet, and it could hint at whether this super-Earth is a promising spot for life. There's even more intrigue in this star system. Scientists think there might be another planet orbiting in the habitable zone, though it's still just a candidate with a complicated name. If it's real, it could be about the size of Earth, making it the smallest planet in the habitable zone ever found by NASA's Transiting Exoplanet Survey Satellite, or TESS. Imagine that. A tiny, Earth-like world sharing the same cosmic neighbourhood as TOI 715b. What makes TOI 715b even more captivating is the possibility that it could be a water world, a planet covered entirely by oceans or hiding vast seas beneath its surface. These ocean planets might not have much dry land with water, or even other liquids like lava or ammonia, covering everything. We can't directly see liquid water on faraway planets with today's technology, but scientists look for clues like water vapour in the atmosphere, which could suggest oceans below. The idea of a planet blanketed in water sparks the imagination. Could there be life swimming in those depths? Hopefully not giant sea monsters, but maybe tiny alien-like creatures. Models suggest that ocean worlds might be common in our galaxy, so there could be countless watery planets out there waiting to be explored. TOI 715b also sits in a mysterious region called the Small Planet Radius Gap. When scientists line up planets by size, they notice a strange gap. There are plenty of planets smaller than Earth, and others bigger than about 1.5 to 2 times Earth's size, but very few in between. It's like a missing piece in a cosmic puzzle. This gap tells us something about how planets form and evolve. Some planets might start out larger and then lose mass over time, like a balloon slowly letting out air, possibly because their star's radiation or winds strip away their atmospheres. TOI 715b, sitting right in this gap, is like a clue that could help scientists unravel this mystery. It might even reveal whether this gap exists around red dwarfs, or if it's more about a planet's density than its size. Speaking of TESS, this incredible satellite launched by NASA 6 years ago has been a game-changer in the hunt for exoplanets. It's found thousands of planets by watching for tiny dips in a star's brightness, which can signal a planet passing in front of it. TESS focuses on finding smaller Earth-like planets around bright nearby stars, making them easier to study with powerful telescopes like James Webb. Unlike its predecessor, the Kepler telescope, which discovered many large Jupiter-like planets, TESS is designed to spot worlds more like ours. For example, it found TOI 700d, an Earth-sized planet orbiting a red dwarf about 100 light-years away, though its scorching temperatures make it unlikely to host life. TESS also discovered planets in the AU Microscopiae system, including one 4 times Earth's size and another nearly 3 times as big, helping us learn how stars and planets grow and change over time. As TESS enters its 7th year, it continues to uncover thrilling discoveries, from sizzling hot Jupiters to distant supernovae. Each find brings us closer to answering big questions about our place in the universe. TOI 715b is a perfect example of why this work matters. It's not just about finding a planet, It's about imagining what it might be like to stand on its surface, perhaps gazing at a red dwarf star glowing faintly in the sky. Could we one day live on a planet like this, billions of years from now, when our sun burns out, its energy fading like a dying battery? Earth may no longer be habitable. By then, humanity might need to find a new home among the stars. Planets like TOI 715b, with their potential for oceans and life, fuel our dreams of distant worlds and remind us that the universe is full of possibilities waiting to be explored. Recently, scientists working at NASA had discovered a brand new planet that might actually be able to support life. This world has been named TOI 700e, and what makes it fascinating is that it is almost the same size as Earth. Even more important, it sits in a region of space where water could exist in its liquid form. Since water is one of the most essential ingredients for life as we know it, this discovery immediately caught the world's attention. But here is the twist. TOI 700e is not the only interesting world in that neighbourhood. Close to it lies another planet called TOI 700d. Unlike Planet E, which orbits in what scientists call the optimistic habitable zone, a place where it is possible that water and even an atmosphere could exist, Planet D sits further away from its star in what is known as the conservative habitable zone. This means that while scientists are unsure if life could truly survive there, they also cannot rule it out. In other words, we may have more than one option for a potential Earth-like world. Both of these planets orbit a star that is only about 100 light-years away from Earth. Now, in everyday terms, 100 light-years sounds impossibly far, but in the vastness of space, it is practically close by. NASA discovered these worlds by carefully observing the light from the star. When a planet passes in front of it, the star's brightness dips slightly, allowing scientists to measure and detect the hidden world. This is the very first time NASA has found a solar system with more than one planet that could potentially host life. So far, astronomers have already catalogued over 5,000 exoplanets, and they estimate that there may be at least 10,000 more waiting to be discovered. NASA specialists are now trying to figure out if any of these planets could actually harbour life. Still, they also remind us that life beyond Earth might not look like anything we expect, since our only reference point is life on our own planet. All of this sounds thrilling, almost like the opening chapter of a science fiction adventure. But before you start packing your bags for Planet TOI 700e, there is one enormous problem: getting there. Humanity has been studying how to live and thrive in space for many decades, and history has shown us how difficult this challenge really is. Back in the year 1962, astronaut John Glenn became the first American to orbit Earth. Even though he only circled the planet 3 times, it took him months of intense technical and physical preparation. Today, our technology is far more advanced, and we can study Mars in incredible detail. Scientists have already discovered that Mars has water and materials that could be useful for human settlers. This has sparked ambitious plans to send people there, perhaps as early as the late 2030s or the early 2040s. If all goes well, the first crewed mission to Mars will be a round trip lasting around 500 days. The length of the journey depends on where Earth and Mars are positioned in their orbits around the Sun. But even if astronauts managed to get there safely, life on Mars would not be simple. After months of travelling in microgravity, their bodies would be weak. Living without Earth's normal pull of gravity causes bones to lose density, muscles to shrink, and body fluids to shift upward, sometimes creating pressure in the eyes and affecting eyesight. Adjusting to Mars' weaker gravity would be another major hurdle before exploration could even begin. Now, if living on Mars, our planetary neighbour, seems tough, imagine the difficulty of reaching planets dozens or hundreds of light-years away. Travelling at the speed of light might sound like the perfect solution, but so far scientists believe it is impossible. To give you an idea, light moves nearly 1,000,000 times faster than sound. At that speed, you could reach the Moon from Earth in just 1 second, or travel from Los Angeles to New York faster than the blink of an eye. Unfortunately, the main obstacle is energy. To move something that fast would require an unimaginably huge amount of it. Currently, our rockets still rely on fuel not too different from the gasoline used in cars, which is far from efficient for space travel. Scientists are experimenting with new methods, such as electric or magnetic propulsion, and one particularly promising idea is the solar sail, an enormous, ultra-thin sheet that sunlight itself can push through space. Spacecraft using solar sails already exist, and experts think they could one day travel up to about 10% of the speed of light. But what if even that is not enough? Some scientists suggest a completely different possibility. Instead of building faster spaceships, why not use planets themselves as our vessels? These would be special types of worlds known as rogue planets, lonely travelers that do not orbit any star but drift freely through space. Think of it this way. Moving to Mars is like moving into an existing house. You still need to adapt to its layout, its lighting, and its quirks. Moving to a rogue planet, however, would be like building a brand new house from the ground up, designed perfectly to meet our needs. Rogue planets may be cold, dark, and seemingly lifeless, but if they have underground resources, they could provide water, constant surface gravity, plenty of space, and even natural protection from harmful cosmic radiation. If humanity ever becomes advanced enough, we might even learn how to control such a planet and generate new types of energy on it. The question, of course, is, where can we find these wandering worlds? Astronomers have already spotted a number of rogue planets in one region of our own Milky Way galaxy. Some were likely kicked out of their original solar systems by powerful gravitational forces, while others may have formed alone from the start. For now, the chance of one drifting into our solar system is extremely small, but if it did, it could disrupt the orbits of our planets, changing the way they receive light and heat from the sun. And if a rogue planet ever collided with Earth, well, that would be disastrous. Still, these discoveries, of planets like TOI 700 E&D, of rogue planets adrift in the galaxy, and of new technologies for travel, remind us that our universe is vast, mysterious, and full of possibilities. Humanity's journey into the stars is only beginning, and who knows what new homes we may one day find among them. To explore some other exoplanets, let's take a look at Kepler-22b, a small exoplanet that lies in the constellation of Cygnus. At first glance, this might not sound too exciting. After all, scientists have found many planets before, but this one is very special. Kepler-22b is the very first planet discovered by the Kepler Space Telescope that sits inside what we call the habitable zone, the region around a star where liquid water could exist. And where there is water, there is always the possibility of life. That is why many scientists believe Kepler-22b could someday become a second Earth for us. Now, discovering planets like this is no simple task. It is not as if astronomers can just point a telescope and spot them right away. Even powerful instruments like the famous Hubble telescope cannot always see these distant worlds, because many of them are far too faint and small, hidden against the blinding light of their stars. The same difficulty appeared with Kepler-22. To find planets in such tricky situations, scientists use a clever method. They take many photographs of the star over long periods of time. Then, they study these images carefully, asking, is there a tiny dark spot moving across the face of this star? If they notice such a shadow appearing again and again, it could mean a planet is passing in front of its star, what we call a transit. From these transits, scientists can learn some very important things. First, they confirm that the planet truly exists. Second, they measure its size, distance, and orbit. And finally, they begin to ask the big question, could this world be suitable for life? So what do we know about Kepler-22b? Quite a lot, actually. For starters, it shares many similarities with Earth. It is about 2.5 times larger than our planet, which means it might hold more water and offer more space for life to thrive. The only downside is that travelling across its enormous surface would take a very long time. Imagine a plane trip lasting not hours, but several days. Kepler-22. B orbits a star called Kepler-22, which is a yellow dwarf almost identical to our Sun. It has nearly the same size, the same radius, and even about the same age, around 4 billion years old. The only real difference is brightness. Kepler-22 shines about 20% dimmer than our Sun. Because of this, you cannot see it with the naked eye when you look up at the night sky. Although we do not yet know the exact mass of Kepler-22b, some estimates suggest it could be up to 36 times heavier than Earth. If that turns out to be true, then the planet's gravity would be about 6 times stronger than what we experience here. To imagine this, think of lifting a bag of potatoes weighing 20 pounds on Earth. On Kepler-22b, the same bag would feel like 120 pounds. Even your own body would feel many times heavier. Walking, running, or even standing might demand the strength of a bodybuilder. Such heavy gravity would also affect life. Plants might struggle to grow upward, and animals would need to be short, sturdy, and muscular to survive. If creatures exist there, they might look nothing like the animals we know. Perhaps stocky beings with many legs for support, built for strength rather than speed. The idea of massive spider-like creatures may sound frightening, but it is not impossible. Fortunately, this is still uncertain. If Kepler-22b's gravity is only slightly stronger than Earth's, then living there would be much easier. The planet is also a little closer to its star than Earth is to the Sun, about 15% closer. If it were in our solar system, it would sit between Earth and Venus. But don't worry, that doesn't mean it's too hot to handle. Remember, Kepler-22 is cooler and dimmer than our Sun, with a surface temperature of around 10,000 degrees Fahrenheit, which allows the planet to remain in a comfortable range for liquid water. Of course, there are still mysteries. Kepler-22b could rotate in unusual ways. For example, it might spin on its side, much like Uranus in our own solar system. That would create extreme seasons, freezing winters followed by burning summers. If the planet were tidally locked, one side would face endless daylight while the other remained in eternal night, leaving only a narrow strip of land in between where life could survive. We still don't know for sure, but scientists hope its rotation is more Earth-like and balanced. Here's the most exciting part. Studies suggest that Kepler-22b may hold a vast ocean. If true, this is fantastic news. Oceans act like a natural air conditioner for planets. They absorb heat, spread it around, and help balance temperatures everywhere. This stability gives life a better chance to grow and flourish. In fact, that's exactly what happened on our Earth billions of years ago. When tiny puddles of water first appeared, they slowly spread across the planet with the help of our moon's pull, cooling the once fiery and hostile Earth and turning it into the beautiful, life-filled world we now call home. So, let's imagine this. If Kepler-22b has water but no protective atmosphere, scientists believe its average surface temperature would be around 12 degrees Fahrenheit, far too cold for humans to live comfortably. But if the planet does have an atmosphere similar to Earth's, then the story changes dramatically. In that case, the temperature could rise to about 72 degrees Fahrenheit, which is just about perfect for a picnic under the alien sky. Now here's another fascinating fact. 1 year on Kepler-22b does not equal 1 year on Earth. Instead, a single orbit around its star takes about 290 Earth days, which is a little over 9 months. That means birthdays and holidays would arrive much sooner than they do back home. But unlike Earth, this planet does not have a natural satellite. In other words, no moon would grace its night sky. We'd have to say goodbye to the comforting glow of moonlight. On the bright side, we might still be able to look up and spot our sun shining far away as a tiny twinkling star. That view could serve as a reminder of home, something to comfort us as long as giant alien spiders aren't lurking around. The truth is, we still know very little about this mysterious world. One of the most important unanswered questions is, what kind of planet is Kepler-22b really? We don't even know if it's rocky like Earth. If it isn't, then much of the information we've discussed so far might not matter. It could turn out to be a gas giant, or perhaps a planet like Neptune with a thick gaseous layer, but a solid core deep within. Another possibility is that it could be a massive water world, completely covered by an endless global ocean. If it is indeed a water planet, then humans might have the chance to build incredible underwater cities. We could filter the alien water, catch and eat alien fish, and maybe, just maybe, start evolving back into amphibious beings. Would that even count as evolution, or would it be a return to our ancient roots? Some astronomers already suspect that Kepler-22b belongs to a class of planets known as mini-Neptunes. Yes, that is a real scientific category, but nothing is confirmed yet. And even if it turns out to be a rocky planet like Earth, we're still left with another great mystery. Does it even have an atmosphere? And if it does, is it friendly to life? Or is it something harsh and deadly, like the atmosphere of Venus? On Venus, the air is so toxic and hot that no human could survive on its surface. If Kepler-22b is anything like that, then the only way to live there would be to dig underground and build hidden shelters. Of course, we'd also need a new heat source, because life underground would be freezing cold. So, as you can see, Kepler-22b is filled with possibilities, both exciting and terrifying. Right now, we don't have a clear answer. All we can do is wait for scientists to discover more before we make any bold plans to send the first humans there. It would be rather embarrassing if we launched spaceships to colonize it, only to find out later that it was nothing more than a giant ball of gas. For now, the only confirmed home of life in the universe remains our own planet Earth. Whether that life is always wise and intelligent is debatable. But what is certain is that humanity never stops searching. Astronomers have already discovered more than 4,000 planets beyond our solar system. And here's the most thrilling part. NASA has identified a special list of 24 planets that may not just resemble Earth, but might actually be better. On these so-called superhabitable worlds, conditions could be even more welcoming than on our own planet. Imagine that. Somewhere out there, there may be worlds more comfortable, more balanced, and more perfect for life than Earth itself. So, let us take a closer look at a few of these fascinating worlds. First, we meet KOI 5715.01. Shall we be coy and mysterious about it? Not at all. This planet deserves our full attention. It lives in the constellation called Cygnus, also known as the Swan. Now, why is this world so special? Well, our own Sun is a yellow dwarf star. It has done a fine job supporting life here on Earth, but honestly, it is not the very best type of star for long-term habitability. No offense, Sun, you are still wonderful, but there are stars out there that can do the job even better. KOI 5715.01 orbits an orange dwarf star. These stars are slightly smaller than our Sun, and they shine with a softer glow because their brightness, or luminosity, is a little lower. But don't worry, it does not mean life under them would be dull or dark. In fact, if a planet like this one lies closer to its star and has a thick protective atmosphere, it could actually appear brighter, more colourful, and even more vibrant than Earth itself. Here is something truly amazing. Our Sun has only about 7 to 8 billion years of life left, which is only a little more than Earth's current age. But orange dwarf stars, they can burn steadily for 45 to 70 billion years. That is far longer, many times the lifetime of our Sun. And this is fantastic news, because it means planets around such stars have far more time for life to appear and evolve. Ideally, if we could find a planet orbiting an orange dwarf that is around 7 billion years old, there is a very high chance that some kind of life has already taken hold there. KOI 5715.01 is estimated to be about 5.5 billion years old. Sure, that may sound a little young, but hey, our Earth was younger than that when life began to flourish. So who is to say what could already be happening there? This planet is located in its star's habitable zone, the perfect distance where water could remain liquid. A single year on KOI 5715.01 lasts only about 190 Earth days. The planet is almost 2 times larger than Earth, and the average temperature there is about 52 degrees Fahrenheit, which is slightly cooler than Earth's average of about 57 degrees Fahrenheit. But thanks to stronger gravity holding onto heat in its atmosphere, it likely feels warmer than it sounds. There is one problem though, it is incredibly far away. This planet is about 3,000 light-years from Earth, or roughly 18 quadrillion miles. Now let us turn to another fascinating candidate, KOI 3010.01. This world orbits a star known as KOI 2010, and it sounds like a truly pleasant place to be. The average temperature here is about 67 degrees Fahrenheit, which makes it a little warmer than Earth. But that is actually good news. Scientists believe the perfect planet would ideally be about 10 degrees warmer than Earth, since extra warmth makes conditions more comfortable and increases the chances for life to appear. This planet has a radius about 1.5 times larger than Earth's, meaning it is a little bigger but still close to Earth's size. Scientists are fairly sure it has an atmosphere, though they are not yet certain what it is made of. Still, many believe it may be similar to Earth's atmosphere. There is also a strong chance of finding oceans there. In fact, water could cover up to 60% of the planet's surface. That is an even better distribution than Earth's, because ideally, a perfect world would have a more balanced mix of water and land. More land means more space and more resources for life to spread. But here is the part that excites scientists the most. KOI 3010.01 is so Earth-like that they estimate there is an 84% chance of the life being present there. Of course, that does not necessarily mean intelligent beings. It could simply mean animals or other living creatures. Still, the thought of discovering alien animals is thrilling. What do you imagine they might look like? Because of the planet's stronger gravity, any living creatures might evolve to be sturdy, with short but powerful legs to handle the pressure. Imagine chunky, tough little beings, adorable, but also a little intimidating. For now, these worlds remain only tiny dots of light in the distance. All we have are dry pieces of data and numbers. We do not even know what they look like yet. To uncover their secrets, we will have to wait until humanity finds a way to get closer. But the possibility is there, waiting for us. Kepler. 186f is often considered one of the finest candidates for life beyond Earth. This fascinating world has even earned the nickname Earth's cousin because of how closely it resembles our home. But remember, it is more like a sister than a twin. Similar in many ways, yet still quite different. This planet circles around a type of star called a red dwarf. Red dwarfs are much smaller and dimmer than even orange dwarfs, but they make up for their faint glow with an extraordinarily long lifespan. Some can live for trillions of years. Since Kepler 186f is closer to its star than Earth is to the Sun, it does not sit in complete darkness. The world wouldn't be night-like gloomy, but the sky would likely shine in a constant reddish glow, almost as if the planet were living under an endless sunset. Imagine walking under skies forever painted in the colours of twilight. Romantic for some, unsettling for others. Would you like to live in a place where the sun never fully sets, the size of Kepler? 186f is very close to Earth's own size, which is both good and not so good. You see, larger planets, those somewhat bigger than Earth, tend to hold on to their atmospheres better because of stronger gravity. That means a thicker, denser atmosphere, which provides extra protection from deadly cosmic radiation, better heat retention, and possibly more oxygen. The downside, of course, is that walking under stronger gravity might feel exhausting. Even getting out of bed on a Monday morning could feel like climbing a hill. Still, a planet like this would have plenty of space for settlements and a shielded, rich environment. Another delightful detail is its axial tilt. Kepler 186 tilts in nearly the same way Earth does, which means it should have steady seasons and a familiar cycle of daylight and night. The importance of this cannot be overstated. For proof, look at Mars. Mars also sits in the Sun's so-called habitable zone. Yet because its tilt is unstable, its climate has shifted so wildly over time that the oceans it once might have had have completely vanished. Today, Mars is nothing but a frozen desert. This shows how small differences in tilt can decide the fate of a planet. But here's the catch. Kepler 186f is extremely far away. It lies about 490 light-years from Earth, which equals roughly 3 quadrillion miles. In other words, we won't be visiting anytime soon, unless intergalactic travel becomes a reality. Before Kepler 186f was found, the crown of most Earth-like went to 2 other planets, Kepler 62e and Kepler 62f. These two also share similarities with Earth. Kepler 62e is about 1.5 times larger than Earth, while Kepler 62f is only slightly smaller than that. Both of these worlds orbit a red dwarf star in the constellation Lyra, located about 1,200 light-years away. The year on Kepler 62 lasts around 122 days, much shorter than a year on Earth. Scientists suspect that both planets may be water worlds. Picture this: warm planets almost entirely covered with oceans. If land exists at all, it may be limited to scattered islands. For some, such a world would be paradise. Imagine living in a planet-wide version of Hawaii. For others, it might be terrifying, as the endless ocean could harbour giant creatures larger than anything we've ever known. Ancient sea monsters like the megalodon would feel right at home there. Still, we do not yet know if these planets have solid surfaces, what their exact composition is, or how dense they are. Those mysteries await future discoveries, and so ends the tour of these super-Earths. Of course, the list of discovered exoplanets is far longer. Thousands have been spotted, many of which share some traits with our own world. Statistically, the odds are good that at least a few of them host some form of life, even if only microbial. But they are scattered across the galaxy, separated from us by unimaginable distances. For now, all we can do is dream. For centuries, humanity has dreamed of colonizing other planets. The idea of settling new worlds is not only a scientific challenge, but also the ultimate cosmic adventure. Mars is usually the first choice for colonization because it is rocky, similar to Earth, and shows evidence of once having water. Scientists and engineers are already sketching blueprints for future colonies on the Red Planet. But Mars is not the only candidate. Let us consider Ceres. Ceres is a dwarf planet that sits in the asteroid belt between Mars and Jupiter. It is the closest dwarf planet to the Sun and is surprisingly small, about the same size as the US state of Texas. Though small, it holds great promise. Beneath its cratered surface, scientists believe, lies a thick layer of ice, and possibly even an underground ocean of liquid water. If that is true, Ceres could become a vital source of water for future missions into the deeper reaches of the solar system. Colonizing Ceres would not be easy, but it is not impossible. We would need protective domes inside its craters to shield settlers from radiation. We could mine regolith, the loose soil-like material found on moons and asteroids, to 3D print the foundations of our bases near the ice deposits. This ice could be harvested to provide water and combined with organic molecules to create fertile soil for growing food. In time, entire underground colonies could flourish beneath the icy crust. Of course, the challenges are enormous. We would need advanced spacecraft powered by nuclear thermal or electric propulsion to even reach Ceres. Life support systems would need to be fully self-sufficient. Colonists would have to adapt to the thin atmosphere, extreme temperatures, and low gravity. Yet, despite the hardships, the potential rewards are vast. New resources, new frontiers, and the first steps toward humanity's expansion into the stars. Let's take a moment to think about what life would actually be like on Ceres. Sounds exciting, right? But then we run into some serious problems. For example, what about extreme temperatures, dangerous space radiation, or the incredibly weak gravity? Gravity is, without a doubt, one of the biggest challenges. On Earth, gravity holds us firmly to the ground. On Ceres, however, gravity is only about 3% of Earth's. That means if you were playing football and kicked the ball, or even just jumped too high, you could literally float off into outer space. Not exactly the kind of penalty anyone wants. But the dangers of weak gravity don't end there. Even if you managed to stay on the surface, your body would begin to suffer the same effects that astronauts on the International Space Station experience. Muscles would shrink and weaken, bones would slowly lose their density, eyesight could get worse, and even your heart and blood circulation could start having problems. Who would have thought that something invisible, like gravity, could be so important to our health? That's why, to survive on Ceres, we would need either an entire team of skilled doctors or some kind of artificial gravity system. And don't forget, weak gravity would also slow down work and production. Imagine trying to build a colony while floating around like balloons. Of course, all this comes with another issue: money. Colonizing Ceres would cost an enormous fortune, especially when you consider all the medical, technological, and structural challenges we just mentioned. Yet, despite these obstacles, Ceres still remains one of the most promising places for colonization. Why? Because this dwarf planet contains valuable substances such as methane and ammonia. These can be turned into fuel, transformed into nitrogen-based gases, or simply mined and transported. Colonizing Ceres could actually help us colonize other worlds like Mars and Venus. And here's an advantage of its weak gravity. It would make launching spacecraft from Ceres incredibly easy. Since rockets would need far less fuel to escape its pull, transportation to other planets would become much cheaper and more efficient. Even if Ceres does not become humanity's permanent home, it could serve as something equally important, a transport hub. Imagine it as a cosmic spaceport, a pit stop where spacecraft could refuel, repair and resupply before heading deeper into the solar system. In fact, Ceres could even become a base for mining resources from the asteroid belt. We could then ship these valuable materials back to Earth or Mars, and for those travelling beyond the solar system, Ceres could act as a refueling station for interstellar journeys. Sounds like something straight out of science fiction, doesn't it? Still, building a permanent base in the asteroid belt won't happen tomorrow. Colonizing other planets is a complicated mission that will demand cooperation between scientists, engineers, doctors, and countless other experts. We will need brand new technologies and a lot of preparation. Before we even think about settling on Ceres, we'll need to build infrastructures on the Moon, Mars, and possibly even at points in between. Otherwise, the project would be so expensive and risky that it would fail before future colonists even arrived. But here's the bright side. The more colonies we create across the solar system, the easier it will become to build another one on Ceres. And once we do, the rewards could be massive. Not only would we gain access to the riches of the asteroid belt, but Ceres would also act as a stepping stone to the outer solar system. From there, humanity could set its sights on the moons of Jupiter and even further beyond. In other words, colonizing Ceres would be more than just survival. It would be an adventure, a way to unlock the mysteries of the universe while building a new home among the stars. Imagine the new culture that could emerge: restaurants with planet-themed dishes, futuristic shops with names like Cerimart, where everything is literally out of this world. Of course, visitors might need special weighted boots just to avoid floating away while shopping. While we've been pouring so much attention into Mars, we've almost overlooked this hidden treasure sitting quietly in the asteroid belt. Ceres might not seem as glamorous as Mars or Venus, but it could be the key to unlocking humanity's future in space. Among the thousands of planets discovered beyond our solar system, one stands out as both mysterious and fascinating: Kepler 1638 b. This distant world belongs to a category scientists call super-Earths, planets that are larger and heavier than our Earth but still much smaller than the giant planets like Neptune or Jupiter. Kepler 1638b was discovered only recently, its existence announced in the year 2016. Yet in that short time it has sparked enormous curiosity. Why? Because in many ways it seems like a potential cousin of our own world. Kepler 1638b is what scientists call an exoplanet. That word simply means a planet outside our solar system. Instead of circling our Sun, Kepler 1638b circles a distant star that is very much like the Sun. Its star belongs to a group called G-type stars. Our Sun itself is a G-type star, so when astronomers found Kepler 1638b orbiting such a star, their excitement grew. A G-type star shines with a golden light, not too hot like blue stars and not too cold like red ones. This kind of star is considered especially friendly for life because it provides a steady amount of warmth and energy for billions of years. The planet's mass, meaning how heavy it is measured to be about 4 1/16 times heavier than Earth. Imagine taking our Earth, multiplying it by 4 and then adding just a bit more weight. That is roughly the size of Kepler 1638b. Because of this, scientists place it in the category of super-Earths. These planets are fascinating because they are big enough to hold thick atmospheres, but not so big that they turn into gas giants. Kepler 1638. B travels around its star at a distance of 0.745 astronomical units. 1 astronomical unit, or AU, is the distance between the Earth and our Sun, so Kepler 1638b is closer to its star than Earth is to the Sun, but not so close that it is scorched beyond hope. The planet takes about 259 days and 1/3 of a day to complete one full orbit of its star. In simpler terms, its year lasts just a little shorter than our own, less than 9 months. If you lived on Kepler 1638b, you would celebrate a birthday more often than on Earth. The announcement of Kepler 1638b came in the year 2016, but the story of its discovery goes back further. The planet was found using data from NASA's Kepler Space Telescope, which was launched in the year 2009. Kepler was a pioneering mission with a bold goal: to stare at a single patch of the sky and search for the tiny dips in starlight caused by planets passing in front of their stars. This method is called the transit method. Every time a planet moves across the face of its star, it blocks a little bit of the star's light. For large planets, like Jupiter-sized giants, the dip in light is easier to see. But for smaller planets, especially Earth-sized ones, the drop in brightness is tiny, sometimes less than 1%. Detecting such subtle changes requires incredibly sensitive instruments and years of patient observation. Kepler watched hundreds of thousands of stars, and among them was the star Kepler 1638. After years of collecting data, scientists noticed that this star dimmed regularly every 259 days. The pattern was consistent, like clockwork, and that told them a planet was there, circling its star with precision. Thus, Kepler 1638b entered the catalogue of known worlds. The discovery of Kepler 1638b was not just another tick mark on the long list of planets. It mattered for several reasons. First, its size is intriguing. Super-Earths are not found in our own solar system, yet they appear to be common in the galaxy. They may have rocky surfaces like Earth or thick atmospheres like mini-Neptunes, and we still do not know which kind Kepler 1638b belongs to. But the very possibility that it could be a rocky super-Earth makes it an exciting candidate for habitability. Second, the planet orbits a G-type star. That is important because most exoplanets discovered so far circle stars very different from the Sun, often dim red dwarfs. Red dwarfs can host planets in habitable zones, but they also flare violently, showering planets with harmful radiation. A G-type star is far calmer and more stable. That stability makes it more likely for life, if it exists, to survive and flourish. Third, the distance of Kepler 1638b from its star places it in what scientists call the habitable zone. This is sometimes nicknamed the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist on a planet's surface. Since water is essential for life as we know it, being in the habitable zone dramatically increases the chances of a planet being suitable for living organisms. Now comes the question that captures the imagination. What might it be like to stand on Kepler 1638b? We do not yet know whether it has an atmosphere, oceans, or mountains, but let us imagine, based on what we know. Because Kepler 1638b is heavier than Earth, its gravity would also be stronger. If its mass is about 4 times that of Earth, then its surface gravity could be nearly twice as strong. That means if you weigh 70 kilograms on Earth, you might weigh 140 kilograms on Kepler 1638b. Walking, running, and even lifting objects would be much harder. Jumping high would be nearly impossible, and every step would feel like wading through deep water. If the planet does have a rocky surface and an atmosphere, the sky might look very familiar. Its star would shine with a golden glow, almost identical to our Sun. Days would feel warm but not scorching, depending on the atmosphere's thickness. Nights would reveal a sky dotted with unfamiliar constellations, completely different from those we see on Earth. Perhaps there could be vast oceans reflecting the golden light of the star, with waves crashing against alien shores. Or maybe the planet is dry and desert-like, with endless rocky plains stretching beneath a blazing sun. The truth is still hidden, waiting for future telescopes to uncover. The atmosphere of Kepler 1638b, if it has one, will decide whether it can support life. If the planet has a thick atmosphere filled with carbon dioxide or methane, it might suffer a runaway greenhouse effect, turning it into a scorching furnace like Venus. If the atmosphere is thin or non-existent, the planet might be barren and frozen, with temperatures swinging wildly between day and night. But if the atmosphere is balanced, with nitrogen, oxygen, and some carbon dioxide, then liquid water could exist on the surface. Clouds could form, rain could fall, and rivers might carve valleys into the land. Life, simple or complex, could have a chance to thrive. This is why astronomers are so eager to study the atmospheres of distant planets. Telescopes like the James Webb Space Telescope, launched in the year 2021, are beginning to analyse the thin layers of gas surrounding exoplanets. Perhaps one day, Webb or its successors will turn their gaze toward Kepler 1638b and reveal its secrets. To truly appreciate Kepler 1638b, it helps to place it in perspective with our own world. Its mass is about 4 times Earth. Imagine 4 Earths packed into one planet that is Kepler 1638b. Its distance from its star is about 3/4 the distance between Earth and the Sun. This means it gets more sunlight than Earth, but not overwhelmingly so. The length of years is about 259 days, shorter than our 365 days. The star type is a golden G-type star, very similar to our Sun. Its discovery was announced in 2016, using data from the Kepler Space Telescope. Every one of these details paints a picture of a planet that feels both alien and familiar. Why do planets like Kepler 1638b matter so much to us? The answer lies in human curiosity and the search for meaning. For thousands of years, humanity has gazed up at the stars and wondered if we were unique, a singular accident of chemistry and chance in an otherwise lifeless universe. The James Webb Space Telescope has given us more than data, more than spectral analysis and probability calculations. It has given us hope. Hope that consciousness, curiosity and wonder are not accidents, but perhaps inevitabilities. The universe, it seems, is not just vast and beautiful and mysterious. It is alive, and so are we.